Kia ora koutou. My name's Bruce Warburton. I work at Manaki Whenua in a research team called the Wildlife Management team, and myself and colleagues work on a range of wild pests, trying to find better techniques for controlling those pests. And one of the pests we work on is wallabies, and there's 5 species of wallabies in New Zealand, 4 in the North Island and 1 in the South Island, centred in around Waimate in South Canterbury. And they've become an increasing problem over recent years because they're increasing in numbers and also increasing in distribution. And now they're south of the Waitaki River and they're north of the Rangitata River. So really for the last 100 years they've been contained sort of between those 2 rivers, but they've now sort of escaped and they're spreading further away from that central area. So the councils that manage those, and DOC, the Department of Conservation that manage these pest species, have a challenge of trying to contain that spread, and they want to try and control those outlying individuals and push the population back into a smaller containment area. But the challenge they have is at the edge of the range of the wallabies, they're in very low numbers and they're very hard to detect. And you can search an area, and if you don't see any, you don't know whether there's none there or whether you just didn't look hard enough, so your detection method mightn't be good enough. And it's a bit like when you might lose your car keys or something and you think they're in the kitchen and you go and have a look and you can't find them, but then your sister or your mother or your wife might come in and say, oh, you didn't have a very good look, and they have a look and they find the keys just sitting there. And so their detection probability, so the chance that they can find those keys, was a lot better than yours. So we're trying to work out what those probabilities are for the detection methods that might be used for detecting wallabies and other pests. And one of the technologies that people are interested in is using thermal cameras. So a thermal camera is one that picks up the body heat of an animal. So you can find animals in thicker habitat in tall tussock and under some scrub that typically you wouldn't see just visually, but the cameras can detect their heat, so they're a bit more sensitive and they should have a higher probability of being detected or detecting those animals. So the councils and Department of Conservation wanted to know how much better thermal cameras would be versus just having a look or using dogs, which is another technique that's used. So we got some funding to do a research project to try and measure that detection probability of thermal cameras. So we had to identify some individual animals and then see if we could find those particular individuals in the wild. So the first thing we had to do was put radio collars and GPS collars on wallabies that we had to live capture. And those GPS collars then told us where those individuals were, and then when we flew over those animals in a helicopter with a thermal camera and detected a wallaby, we could say that was one of our marked animals and therefore what the probability was of detecting it. So the first challenges were catching these animals live, and behind me I have some photos, and we live captured wallabies with net gunning from helicopters, and you can see in this photo here the chap in the helicopter using a net gun. He's just reloading the net gun up to do some more live capture, and we use ground netting as well, and another photo here with a ground set net, if you can see that. And here's a wallaby entering one of those nets. And then the following morning for the ground captures, we can recover those wallabies and put a collar on them, as you can see in this picture here. So this is the collar here. It is quite bulky because of the new technology that we had to use. So we couldn't buy any commercial GPS collars that would do what we wanted to do. So we had a colleague within Manaaki Whenua develop these collars specifically for this research project. And the reason we couldn't buy a commercial product is we needed very, very high frequencies of fixes. So we needed a fix every 2 or 3 seconds. And the fastest capture rate that we could get commercially was about 2.5 minutes. And animals can move a long way in 2.5 minutes when you're flying over them. So when you're flying over them, we need to know where the wallabies were exactly at the point in time when we might fly over them. So that's why we needed these specially designed radio collars and GPS collars. And because we were taking very high frequency fixes, they really chew through the power of the batteries, and that's why it's got a very large case here for a large battery. And we wanted to be able to turn off that high frequency capture of data when it wasn't needed. We just needed the fast fixes to be captured when we were flying over and actually doing the surveys. So that needed another bit of high tech put into these collars, and we used a new sort of radio protocol called LoRa, long range protocol. And so up in this part of the collar, so the collar fits around the animal like this, so the GPS chip system is in the top of the collar, and the LoRa radio is there as well, and it's all powered by the battery. This part here is a VHF collar so that we can radio track the animal after the trial and recover the collar. And the LoRa radio technology allows us to talk to the collar and turn the fast fix on and then turn it back off again. So the LoRa radio system in here talks to what's called a gateway. So it's an aerial system that we put up. And so in an area we had 3 of these gateways. And this talked to the LoRa gateway and then through the cellular network through to our internet, and we could check where the animals were at any time of day that we wanted to. And then the other way, through the internet, we could talk back to the collars through the cellular network and then through the LoRa system to turn the fast fix on and off when we needed it. The results we've got, I don't know whether you'll be able to see them, it's just a wee map here, and it just shows some of the individual sort of home ranges of the animals that we've been tracking. The typical home range size of the wallabies turned out to be about 15, 16 hectares, so they're not huge, but some of them do have individual, so yeah, some of them have individual movements that are a bit further than, or a bit outside that sort of fixed area of 15 hectares. Yeah.
Thanks, Bruce. We've got some questions coming through.
Yep.
Sally has asked, would eco-node gateways work too, or do you need another system?
Eco-nodes are really useful for monitoring traps, but they do use LoRa, which is really good. So similar technology, but we're just using it a wee bit differently. Yep.
And what kind of challenges have you found with this new technology?
The biggest challenge is collar size and the battery, the power. Having very frequent capture of data means that the power is drained very quickly. So even with being able to turn it off and on, we still only got 2 to 3 months maximum out of it. Yeah.
And is something like weather dependency a problem?
Not in terms of the technology, well, not in terms of the collar technology. It was in terms of doing the survey. Of course, we could only do the thermal surveys in good weather or cool weather. Yeah, we didn't want sunny days because that warms all the environment up and you can't detect the wallabies so well. Yeah.
With this capturing data at such a fast rate, how has that sort of changed your, from a science perspective, view on how many wallabies you can see? Has it been a huge increase?
The technology hasn't really helped that so much. the fast capture rate has given us a really good look at fine scale movement of animals and how they use that habitat, and that's something that we've never had before, and we don't really have for many, if any, species at all. Yeah.
Is this kind of collar something that you could see working on other species?
Yeah, as long as they're larger than wallabies. We couldn't design this technology to last that length of time for smaller animals. And again, it's because of the battery. It's really limited by the battery power.
Talking back to the issue of wallabies in New Zealand, where have you seen across the country has the biggest problem?
So right at the start I said we have 5 species in New Zealand. So there's 4 on Koware Island. So there's a swamp wallaby, a brush-tailed rock wallaby, a palmer wallaby and a dama wallaby. And they were all introduced back in the 1800s by Sir Governor Grey, the first governor of New Zealand. And then dama wallabies were translocated from Koware Island to Rotorua. And as for the wallabies in the South Island, which are Bennett's wallabies, that's the largest wallaby, the dama wallabies around Rotorua are also increasing numbers and spreading. And the same issues that we're having in the South Island are having in the North Island. How do we contain that spread? How do we detect them at the edge of their range, and how do we remove them? Yeah.
Got another question come through. What thickness of the canopy restricts the thermal imagery?
Good question. So thermal does improve detection, but it's not a silver bullet. So as soon as animals go into thick sort of matagari scrub, you will lose that detection using thermal. Under forest canopy, it really depends on whether there's openings. So sometimes you can pick up animals on the ground in a forest if the canopy is not dense and complete. But if you've got quite dense and complete canopy, then the thermal won't work. So it's better than visual, but you're not going to detect everything. And that's part of our research, is to work out what proportion of our marked animals were we actually detecting. So we were seeing lots of wallabies, but we weren't always seeing our marked animals, our collared animals. Yeah.
What's next for the collar and research in this project?
Well, we've just completed our 3rd and last trial, so now we just have to analyse the results. We've been comparing thermal cameras with dogs and fixed trail cameras, and just an observer in a helicopter. So we're looking at how the detection probabilities compare across those 3 or 4 different methods. Preliminary look at the data after the 2nd trial, it looks like dogs were the best, but they can only cover so much ground in a day, where a helicopter can cover a lot more ground. So there's sort of costs and benefits for each of the methods.
Cool. And something like this and this sort of technology, if you can just explain again, where does this end up? Does it go to DOC? Does it go to government? Does it go to people who can everyday use?
Right. So the results go back to MPI, who funded this work through the Sustainable Farming Fund, and we got co-funding from the Otago Regional Council, Canterbury Environment Canterbury, which is really good. So the results will go to them, and it will go to DOC, and it'll help them decide how much survey effort they need to put in to decide that wallabies are there or not, or they've been eradicated. So it's really about, when you search an area and you don't find a wallaby, how confident you can be that there's no wallabies there. If you detect a wallaby, then you know they're there, and that's not that critical. It's around when you don't detect them, what's the probability that there's nothing there? It's a bit like your lost keys.
And so with wallabies, I imagine quite a few people would be surprised that we even have them in New Zealand as a problem.
Yep.
So are you able to talk through a little bit more about their breeding cycle and just the scale of the problem? Yeah.
Wallabies, like possums, only have 1 offspring a year, but in South Canterbury there was only 4, I think it was. It was either 2, it's a bit uncertain, either 2 or 4 individuals were liberated on a farm near Waimati, and they were introduced for sport. And now they've spread right through the Hunter Hills, across towards the Mackenzie Basin. There's been a recent sighting just up in the Ashburton Lakes at Lake Heron, and as I said earlier, they've spread it across the Waitaki and the Nara and Otago, so around Naseby. They've been found north of Christchurch. I've seen one at Mount Oxford, so inland from Christchurch a few years ago. So some of those more distant sort of identifications are probably not natural dispersal. They'll be sort of irresponsible individuals releasing animals, which is not a good thing. But yeah, they only have one a year, but that's just enough. Like possums, over time they just disperse and they increase in numbers. And in the South Island and Canterbury, they have a big impact on farming productivity.
We've had another question. What spacing do you use on your trail cameras?
What?
Spacing.
Spacing. The trail cameras were set about 200 to 300 metres apart.